Dear students, in this video I will define the dual of a basis of a vector space and then I will give an example. Let BF be a finite dimensional vector space with x1, x2 shown up to xn as its basis. Then the basis f1, f2 shown up to fn of B star such that fi xj equal to 0 if I not equal to j, 1 if I equal to j is called the dual of the basis x1, x2 so on up to xn of V, or simply dual basis of B star. So let us give an example. Let B be the set containing vectors x1, x2, x3. Let it be a basis of vector space B equal to R cube, where x1 is -1, 1, 1, x2 is 1, -1, 1, x3 is 1, 1, -1. So let us find dual of the basis B of vector space B equal to R cube. Since dimension of a finite dimensional vector space V is equal to dimension of its dual space, dimension B is equal to dimension B star, and dimension of B is 3 because B is R cube and dimension of R cube is 3. Therefore dimension of B star is 3. And so the basis of B star will contain 3 elements. Therefore, dual basis of V will contain 3 linear functionals. Let B star be the set containing linear functionals f1, f2, f3, and let this B star be dual basis of V such that fi xj equal to 0 if I not equal to j, 1 if I equal to j. Our aim is to find the linear functionals f1, f2 and f3 defined like this. Fi xj is 0 if I not equal to j, 1 if I equal to j. Let f1, f2 and f3 be defined like this. f1 xyz equal to alpha 1x plus beta 1y plus gamma 1z, f2 xyz equal to alpha 2x plus beta 2y plus gamma 2z, f3 xyz equal to alpha 3x plus beta 3y plus gamma 3z. We have f1 x1 equal to 1, f2 x1 equal to 0 and f3 x1 equal to 0. Now f1 x1 equal to 1 implies f1 -1, 1, 1 equal to 1. Substituting the values of x, y and z here, x equal to -1, y equal to 1 and z equal to 1, we get minus alpha 1 plus beta 1 plus gamma 1 equal to 1. Let it be equation number 1. Also f1 x2 equal to 0 implies f1 1 minus 1 1 equal to 0. Again substituting the values of x, y, z here, x equal to 1, y equal to -1 and z equal to 1, we get alpha 1 minus beta 1 plus gamma 1 equal to 0. Let it be equation number 2. Similarly, f1 x3 equal to 0 implies f1 1 1 minus 1 equal to 0. So this implies that alpha 1 plus beta 1 minus gamma 1 equal to 0. Let it be equation number 3. Now we have 3 equations in 3 variables alpha 1, beta 1 and gamma 1. On solving these equations for alpha 1, beta 1 and gamma 1, we get alpha 1 equal to 0, beta 1 equal to 1 by 2 and gamma 1 equal to 1 by 2. Therefore, f1 xyz becomes 0x plus 1 by 2y plus 1 by 2z, which is 1 by 2 into y plus z. Similarly, f2 xyz equal to 1 by 2x plus 0y plus 1 by 2z, which is 1 by 2 into x plus z. And f3 xyz equal to 1 by 2x plus 1 by 2y plus 0 into z, which is 1 by 2 into x plus y. And therefore, b star equal to 1 by 2 y plus z, 1 by 2 into x plus z, 1 by 2 into x plus y is the dual basis of the basis B of vector space V.